Hello everyone, I'm Hae-Na Lee from Stony Brook University. In this presentation, I'll talk about our work on understanding how the presence of out-of-vocabulary words impacts the Twitter experience of blind users. People who are blind interact with computing applications, including social media, using screen reader assistive technology. A screen reader speaks out the content on the screen by converting text to speech. However, the language of social media is well known to be highly informal, and as such, it does not follow canonical spelling, punctuation, capitalization, etc. Social media text typically contains many out-of-vocabulary words that are not present in standard dictionaries, and therefore, there are no corresponding standard pronunciations that screen readers can leverage to narrate such out-of-vocabulary words. Hence, it is unclear if blind screen reader users can easily understand tweets containing out-of-vocabulary words, even though these tweets are technically accessible. Here are a couple of tweets which blind users may find difficult to comprehend due to out-of-vocabulary words. For example, here is how the first tweet is read out by the voiceover screen reader.
1 minute IMSCREAMINGGGGGGG.
In order to understand more about the influence of OOV words on blind screen reader users, we set two research objectives. First, we examined how screen readers handle the OOV words. Second, we investigated how the presence of OOV words impacted the Twitter experience of blind users. For the first objective, we created a custom dataset of OOV words by extracting these words from tweets containing at least one OOV word. As OOV words are inherently heterogeneous in their underlying purposes, we grouped these words into 6 categories and 16 subcategories. Then the annotators manually examined how OOV words were narrated by 3 most popular screen readers, JAWS, NVDA, and VoiceOver. We used 4 classes to describe screen reader narration behavior. Word if the screen reader pronounced an OOV word as a complete word. Spelling if the screen reader spelled out an OOV word. Word spelling combination if the narration behavior was a combination of word and spelling. And word autocorrect if the screen reader narrated the corresponding standard word in place of the OOV word. We found that all 3 screen readers had tendencies to read out OOV words as complete words, and moreover, they rarely performed autocorrections. Also, we observed undesirable narration behavior for some of the OOV word subcategories, such as acronyms and initialisms. To determine how the linguistic aspects of OOV words influence screen reader narration behavior, we first handcrafted a set of linguistic features, and then we built prediction models for each screen reader using these features. Analysis of these models revealed that OOV words that have more vowels, or those that are longer, are likely to be pronounced as complete words by all 3 screen readers. On the other hand, OOV words with more uppercase letters were likely to be spelled out. Also, autocorrections were mostly influenced by the presence of specific letters of the alphabet, which strongly indicates that autocorrections are mostly simple keyword lookups. To understand how OOV words impact the Twitter experience of blind users, we conducted a user study to address 3 research questions. 1. What types of OOV words blind users typically employ in their tweets? 2. What types of OOV words blind users find hard to understand? And 3. What strategies blind users apply to understand OOV words? We recruited 15 blind participants for the study. These blind screen reader users were familiar with Twitter, and they exclusively relied on screen readers to interact with tweets. The study consisted of an initial interview asking participants about their experience with OOV words, followed by a set of tasks that included OOV word recognition and tweet comprehension. In the study, blind users stated that they preferred to use only a few select well-known acronyms and abbreviations. They also liked to use emojis, but only 1 or 2 per tweet. All participants felt that slang added flavor to their conversations. The participants also mentioned that they avoided shortening words and misspellings. The participants mentioned that acronyms and initialisms were most often hard to understand. Also, they felt that slang was not a problem, and phonetic substitutions disrupted a smooth listening experience. The task results also showed that spelled out OOV words and tweets without OOV words had higher comprehension accuracy. To understand OOV words, the participants listened to the containing tweets or tweet portions multiple times, while relying on surrounding standard words to guess the meanings of the OOV words. Many participants also used screen reader shortcuts to listen to the spelling of the OOV words and then mentally guess meanings. They also often searched on Google, asked their friends, or leveraged custom pronunciation dictionaries. Informed by our analysis and study findings, we suggest 3 ideas to improve comprehensibility of OOV words for blind screen reader users. 1. Text normalization, which is to replace OOV words with the corresponding standard words. 2. Force screen readers to automatically spell out selected OOV words. And 3. Enable users to easily query the meanings of OOV words and vocally specify custom pronunciations for these words. Thank you very much, and please refer to our paper for full details.